All right, now we're going to be working on question 2.4i. It says a ball is thrown up into the air and is caught by the thrower after a certain amount of time, and our total time goes here. Now, my code's 2, so I'm going to be 0.2. It's a little bit unrealistic, but it's what we have. Now that you have the total time, if you were to break this up into separate segments, the time on the way up is equal to half of the total time. And here are some other givens that we have that it's assumed that we know it. Acceleration, final velocity at the top, or the initial velocity on the way back down is equal to 0. So the first question says to us, for part A, what is the initial velocity when you throw the ball up into the air? So we're trying to solve for VI. Step 2, I'm trying to solve for VI of chapter 1A. Step 2, what are my givens? Given VF, T, and A. Step 3, now I'm only sticking with the up trip, or what we like to call chapter 1A. I'm going to use VF equals VI plus AT. Now, that's equal to 0. That's VI plus negative 9.8 times 0.1. Step 5. Now, I don't need the calculator. Just multiply negative 9.8 times 0.1. It's VI is equal to 0.98. Just move the decimal place over 1. Now, the reason why it becomes positive and not negative is because that VI, when it goes over the equal sign, you kind of have to make your unknown, put the unknown by itself, the two negatives. So when I bring this VI over the equal sign, it'll become negative VI, and so these two negatives will cancel each other out. So that's our answer here for part A. And for part B, it says what's the distance, the height, to how high does the ball reach? So step number 1, you're trying to solve D for the first part again. Step 2, our givens are, we have VI now. We have VF, A, and T. Step 3, we can use a whole bunch of equations. Maybe we'll just use D is equal to VI plus VF over 2 multiplied by T. Step 4, D is equal to 0.98 plus 0 divided by 2 multiplied by the time, which is just going to be 0.1. All right, so on the calculator, we got this. 0.98 divided by 2 multiplied by 0.1. So our distance is not that realistically high, but it's an answer nonetheless for our code. So D comes out to be 0.049 meters.